In order to run cut fill volumes in area where substrata is present, all we need to do is have some 3D meshes that represent those rock layers. So to illustrate that, I've just created some terrains here. I got these from boring files, XYZ data of the different layers on my site. I created terrains from them. These terrains have a volume option of none because we're just going to use them to actually create the 3D meshes of the actual rock strata in there. So we to do that, we're going to go over to the Model Detailing tab, and we're going to do the Create Closed Mesh. And so on this top level, between those top two surfaces, we're going to do element to element, and we're just going to call that a rock layer up there. Element to element, the top surface is this one, the bottom surface is this one, and we'll accept it. For the next one, we're going to run that command again for the next layer, and that was, we will call a sandstone layer. And element to element, the top surface is this surface right there. The bottom surface is there. We'll accept that one. And then underneath there, we're going to have a layer according to the geotech report. It just goes down and it's limestone down from there on. When we run the create closed mesh, in order to model that, I'm just going to say element to depth, and I'm just going to put in a depth of 10 feet there for my limestone layer, just to make sure it goes down far enough so that if I encounter it, I don't have very deep cuts on my project here, but if it does encounter it, I think having 10 feet there will cover any possible cuts that I have on my site. So I'm going to select my top surface, which is that bottom one, and it's just going to go 10 feet down from there. So there I have modeled now my 3D meshes that I can run volumes against. So all I have to do is reference that into my corridor file. So we'll switch over to the corridor file now. Okay, once the corridor file comes up, I just need to make sure that rock mesh DGN is referenced into that, and I have it here, so we will turn that on. And once I do that, I can step through my cross sections and I can see those different meshes being displayed there in my cross section. So all I need to do now, like I've done with all the other types of volume calculations, is go back and run the Create Cut Fill Volumes tool, and it will recognize now those meshes. It'll calculate the cuts down to the top of those substrata layers. I'm going to turn on Compute Substrata this time. Scroll through there. And when that gets done calculating, it's going to calculate the cut down to the top of the substrata, and then it's going to give us individual quantities for the different substrata layers that are being cut by the design features. So let's go ahead and step to the next station there. And we can see that that red cut layer is doing good. It's going to the top of my substrata layers, and it's going to calculate all my substrata cuts in there, like that portion there from that limestone layer there. So let's look at that in report. We'll go to compute report, compute by name boundary with no name boundary, just to get a good report of it all. And we can see we have the totals there, but I like to go down to volumes.xsl, and I can see how much rock is going to be removed from that top rock layer. I can see how much sandstone layer is going to be removed and how much of the limestone layer is going to be removed, and it'll total all that for me down here. And just one thing before we leave, let's just look at that feature definition used by those substrata layers. If we go into our feature definitions, go down to mesh, and I have those under existing, and we'll look at sandstone, for example. Okay, here we have we can see that our volume option is set to substrata, and we can do, again, cut factors on that. We can tell whether we can use this cut in the mass ordinate and other places on the job site there.